Hey guys, Hydra66 here, and today I was going to do a tutorial on a multi-threaded socket server in C Sharp. So basically, to get started here, I'm in Visual Studio. 2013 is pretty sick, by the way. Their web design one is pretty cool too. Haven't had much time to check that out, but basically, this project's going to have three parts to it. So we're going to create a blank solution that's down here in Templates, Visual Studio Solutions, blank solution, server. No. Okay. So basically, we're gonna have our empty solution here. We're gonna add three projects to it. We're gonna add a console application. We're gonna call it server. I can be moving kind of quickly, by the way, just because this is gonna be a lot of time, and I want to get through it as quickly as possible. New some client. And then we're going to add a class library, and we're going to name this server data. And we're going to, oh Jesus, those are all in VB. Never mind. Shoot, sorry. And I'm getting over a little bit of a bug here, so it might sound a tiny bit sick. Okay, C Sharp, there we go. All right, sorry about that. Client. Server, and then the remember this last one's got to be a class library, and this can be called server data. Okay, let's just for kicks and giggles call this class packet. Yes. Okay, so I can rename my classes so I know which one's which. This one client, oh Jesus, client server. Okay, so we're good to go. So I'm gonna kind of give you an overview. This is has a lot of moving parts, so to speak, but I'm gonna start programming the server side of things, and we're gonna import a few libraries we're gonna be using. Actually, even before all of that, we're gonna add a reference to our server data library. So if you don't know what a class library is, basically all of these are libraries of code that we can already that they've already been written. We don't need to rewrite them. We can just use them. So to add a reference to our server data class library, which is actually in our project, we just need to click on the project we want to import it into, add, and then add reference. And then you're going to come up here to solution. If solution's not already clicked, you're going to click server data, do OK. Then from there, you just need to go using server data. We're going to do the same thing for our client. Server data. We're at a client. Using. Okay. So, oh, wait, what did I just do? Oh, old packet. Oh, that's right. Okay. Using server. All right. So, basically, there's a lot of sides to this, and the reason we have this server data class or this packet class is because we have two projects here that are actually going to be running in two separate executables, and we need data to be able to go between them and be recognized on either end. So that's why we use a library, because it kind of standardizes things. But basically, I'm going to get started in the server here, and I clear out the main method. Let's forget about this main method right now. I'm just going to kind of line this out in comments for you, because it's a little bit. Basically, we are going to have. You're going to need a socket, which is going to be your listener socket. Sorry, more imports. We're going to need using system.net.sockets and using system.io. And then there's one other you're going to need in the packet class here. Just switch for the packet. You're going to need using system.io, and you're going to need using system.runtime.serialization.format. It's a binary. And basically, what a binary formatter is just a way to compress a packet into a string of text or a string array of bytes, and then it's easy to transport from there and deserialize, but I'll get into that later. So we're going to need a socket up here. So socket, I think it's going to need to be static socket, listener socket, and we're not going to initialize that yet. And then we're also going to need a couple things. We're going to need another class down here. Oh, And I'm just going to create this in the server class because the server class is the only one that's going to be using it. And then it's going to be called class client data. And then this class is going to have a few variables. We're going to need a public socket, client socket, and a public thread. We need system.threading, excuse me. Making a threaded server, why wouldn't we need system.threading? Okay, system.threading. So we should be all good there, and then public thread, client, I don't need that, client thread. Okay. And we're gonna have to give it a string, public string ID, so that we can identify this client apart from the rest. And how about, let's do, we don't need IP. So in the constructor, I'm just gonna do public client data. I'm just gonna create a blank one. I'm gonna create data. I'm gonna have client, or probably socket, client socket. So we're gonna go down here and we're gonna need to assign our client socket to this. So client socket, or actually, excuse me, this dot client socket, there we go, is equal to client socket. So that way, by using this, it'll be able to identify between this client socket and that client socket. And wow, I'm already at 6 minutes, so I'm gonna speed up a bit. So basically, also the other thing we need to do in both of these is assign this ID, and for that I'm going to use something called the GUID, so I'm going to go basically ID is equal to GUID, and I'm going to do new GUID, and I'm going to do .toString. So that's basically going to give it a random string of text, which will be different from any other ID that it will generate. So then we can identify this client as a unique client. So until I get into the client thread here, I'm just going to put a little comment after that and remind myself to do that. But basically we need a few things up in here. We need a static list of client data. Which calls clients. We're not going to initialize any of this yet. This will all happen in our main function. So we're going to need a few methods here. First one is going to be a listener that listens for client. I probably misspelled half those words. Clients, jeez, clients trying to connect, and we're gonna need a client data thread which receives data from each client individually. And then we're gonna need, on the main thread is where we start our server. I'm just gonna put start server, initialize all of our objects up here. Basically, let's see what else we're gonna need. Probably some sort of data manager. Manger. This is in French. Manager. Okay. Data eater. Okay. So basically, I'm just going to do the start server function here, and we're going to assign our listener socket, single new socket. We're going to give it an address family of internetwork, so we can just test it over LAN local area network. We're going to give it a socket type of stream, and we're going to give it a protocol type of UDP. Actually, no, let's do TCP. So protocol type is TCP. We also need to initialize our clients. New. There we go. So there's one thing we're going to need to do here, and we're going to need to do it's going to be a get IP thread. And why don't we just put this in our packet class? It's shared between the two already, because we need this in our client thread as well. So we're going to create a public, has to be static, static string IP get IP for address. And basically we're going to need using system.net up here, and go ahead and do we need array of IP addresses. IPs is equal to DNS get host addresses, and the parameter or argument we're going to give it is DNS.getHostname. There we go. Okay, so basically this is going to get all the IP addresses. So when you go into command prompt, do IP config, all of these IP addresses are going to show up. So we need to make sure that we're just getting the IP4 address. And by doing that, we're going to go for each IP address in IPs. Oh. Excuse me. For each IP address I and IPs, if I dot address family is equal to address dot internetwork, we're going to do, and I don't want to import this, so I'm just gonna, that's the only time we're gonna use it here. So we're gonna do so I don't need those, return I.toString, and basically if can't get that, we're just gonna return 127.0.0.1, which is essentially the computer's just default IP address, I guess you could say. But anyway, that's our get IP4 address method, and I'm gonna move back over to the server here. And what we need to do is sockets. There's kind of two ends in Java. There's a server socket, and then there's also a regular socket. But C# is better because there's only one socket, and you can use it for both. All you have to do is bind it to this machine. So we're going to create an IP endpoint here. Actually, I'm going to, excuse me, got listener sockets ahead. Dot bind, and it's going to take this this is .net.local IP endpoint. So I'm going to come up here and I'm going to import using system.net. I'm creating an IP endpoint right here, and basically an IP endpoint is just IP is a new IP endpoint. It's going to take an IP address. We're going to do IP address.parse packet.get IP4 address, which was our method that we just wrote, and then we're going to give a port. So I'm going to go ahead and use 4242 because that is the answer to life. Then we're just going to use this as our argument when we're binding. So that should be all good. Basically, all we need to do from here is create our listener thread and our data thread, and our data manager will be done with our server side. And I'm at 12 minutes. See, that's really just going to take a while. So basically, for the listener, we're going to have public, not public, excuse me, static void listen thread. And no arguments, no parameters, since we have everything declared as fields at the top, which is convenient. Basically, we're going to go ahead and tell our listener socket to listen. Figure that. Big surprise, right? Listen. And then basically what this is doing, forget about this. This isn't really important at the moment. That's just the backlog. So don't worry about it either way. But basically we're going to have, we're going to access this client list. We're going to add new client data for, actually, I need to start a new thread. Not yet. Okay. In fact, yeah. Sorry, I'm trying to not jump around. It's just my ADHD brain does that a bit. So we're going to go ahead and add, go to our clients list and then add new client data. Watch this. Listener socket.accept. Wow. It's not impressive. No. But basically we're just adding new client data here, and we're going to tell our listener socket to accept the connection because it's listening. You know, it's going to see a connection if it's listening, but it's not going to know what to do with it until we tell it to accept the connection. So basically this right here just returns a socket. So this client data, we're basically just giving it the socket argument that it needs. But that's going to add that, and it's going to assign a new GUID, and it's going to add a client to this list right there. So the problem is we don't want to be able to just accept one client and be done, right? We want to be able to accept clients indefinitely. So what we're going to do is, for some, so we're going to create an infinite loop here. And fuck the police, I know people do it while true, but aren't you special? Okay, for some, so that'll create an infinite loop here. So this will just run until the program closes, essentially. And I think that's about it we need for the listener thread. Now, because it is a threaded server, what we need to do is we're in our main method where we start a server, we need to create a thread. Listen thread is equal to new thread. Listen thread. So if you're not familiar with threading, Essentially, it's just a way to accomplish multiple tasks at the same time, or quote at the same time, unquote. And it doesn't actually happen at the same time, but it simulates happening at the same time. It's basically just another thread that your CPU cycles through, because it's constantly, every time it refreshes, it cycles through all the threads that are running in your computer. So we're creating a thread here, we're naming it listen thread, and the argument we'll be giving it is this method. So this is the method it'll run when it starts. So we're just going to do listen thread.start, and then we should be good to go in terms of our main method. I'm not sure yet though, but I'm pretty sure that's about it. So just to recap, we're signing our socket, we're initializing our socket, initializing our client list, creating an IP endpoint with this computer's IP address and 4242, and then we're binding that to our local, binding the listener socket to our local IP address. And then we're starting this listen thread and creating it and then starting it. So we go and close that out. The next one we're going to need here is the client data thread. So static, this one needs to be public, and actually, yeah, public static void. I'm gonna call it data in for, and this one is gonna need an object. This parameter is gonna be, we need to make it an object, and we're gonna make it client socket. Actually, I'm just gonna name this socket because I want to use client socket in the method. Okay, so basically the reason we're giving an object and not an actual socket, because we need to start a thread, and you want to pass it a parameter when you start it. It just makes it a lot easier to use an object and then cast it over it once in the method, because otherwise you have to use parameterized thread start, and it's just a pain in the ass. So we're just going to create socket clients socket is equal to socket c socket. Okay. So, this is where things get kind of heavy. We're going to need a couple of things here. We're going to need a byte array. We're going to call this buffer just for the sake of standardization. We're going to call this, create an integer. We're going to name this red bytes. So, we're going to come down here. We're going to create another infinite loop. They're not actually infinite. I'll explain that later. But basically, we're going to do, let's see, which one is it? Buffer is equal to new byte, and we're going to create this. When we initialize it, we want it to be the same size as our client socket's send buffer size. So send buffer. It's gotta love those array out of index errors, right? Basically, we're going to also next thing we're going to do here is to read bytes is equal to client socket dot, oh geez, dot receive, and then for the argument here we're going to use our buffer. So read bytes is just telling it how many bytes it got from this it read. So this is, it's constantly reading, so it may not get any information. This is why we need to do this. If if read bytes is greater than 0, then we'll have it do the information in here. But if it doesn't read any bytes, then there's no point of cycling through all of our data, and then that just presents more possibilities for errors. So we're just going to have it not do anything if it doesn't read any information. Basically, it's receiving the data. The buffer contains the data in it. So, for the moment, let's do and data here. So, if you're just kind of trying to get the gist of this project, basically, this is where your buffer is the data that you got from your client, and you do whatever you wanted to here. But I'm going to keep going because we're trying to make a little chat room here, right? So, basically, going back to our client data, we now need to do the client thread side of it. So, client thread is equal to new thread, and we're going to give it the server dot data in method. What are you talking about, Willis? Frick. God damn it. I'm gonna pause it really quick here. Okay, it's got to figure it out. Sorry about that. I was accidentally doing that, and that implies a parameterized should start, which is what I hate in the beginning. So we're just going to give it the method name. I forgot about that. So client thread.start, and then this is where we give it its argument, client socket. So then we're going to also copy this over to there, so it'll be doing it in both. But basically, this just reads data from the client. That's why we keep it in our client data, because we know that it's per client. So this is just reading. This is getting the data from each client that connects, if they send data, that is. So how do they send data? So let's go over to this packet class. There's a couple things we need in here. How I generally like to structure this is kind of based on opinions. It's just a way to easily send data over the network, or through the socket, or so to speak. So the way I like to do it is I like to create a public list string, call this data, G for general data. I'm going to also do some other data types. I like to have public and packet, and because you never know you're going to send public bool, packet bool. So we're also going to need public ID send, public string sender ID. Okay, so basically we're going to create. It's going to take a couple. Actually, no, there's one more thing we need here. We're going to come down here. We're going to create an enumerator. We're going to do public enum packet type. So for now, we're not going to have anything there, but we're going to create a public packet type. Packet type. Okay. So just for an enum is just a general way of creating categories. So I could create packet type.cool packet or packet type.warm packet. You need to separate them with commas, and I can just do whenever I want to assign it. I can do like type is packet type dot. Oh well, I'm in the class, so it's gonna get all butt hurt. But anyway, it's just a general idea. Delete those. Okay. So I'm going to create one constructor that just takes public packet, and it's just going to take a packet type argument, parameter, excuse me. So G data is equal to new list string. We just we don't need to initialize any of those. Don't need sender ID, except that should probably be an argument. String ID. Okay. So basically sender ID is equal to, or actually forget this dot sender is equal to sender ID. Okay. So this dot type is this. Oh my god. Oh, packet type. There we go. It's equal to type. All right. So basically, this constructor just initializes what we need to initialize, and it gives it a type, and it gives it a sender ID, which will be the GUID, or in the server's case, it'll just be server, something like that. But there's also another method we need down here, and this is where you get some cool stuff going. This is how we're going to save our packets. We're going to name public bytes to bytes. And basically, this is going to turn all of this information, this entire object here, from beginning to end, once it's been initialized, into an array of bytes. And how we're going to do that is we're going to use a thing called a binary formatter. BF is equal to new binary formatter. And this is held in this import format as runtime.serialization. If you're familiar with JSON, it's essentially the same thing, but this is just, I found that, well, you don't have to like import your own library for JSON in this case, and then also it kind of obfuscates it a little bit more than JSON does. So I guess if you're looking at things from the security standpoint, that could be better. But we're also going to need a memory stream, which also makes it really easy to do new memory. No. Makes it really easy to convert to and from bytes. So, basically, all we need to do here really is just bf.serialize going to be the stream, so memory stream ms, and this implying are the object that we're contained in. So we can do ms.close. Actually, no, we need to create bytes is equal to ms.2byte to array. There we go. And then ms.close. Always remember to close your streams, just a good habit. So we're just going to return this bytes. So that's our 2bytes method. So from there, actually what we can do to make ourselves life a lot easier on ourselves, we can just create another constructor here, public packet, and just have it take a byte array, packet bytes. And so by doing this, we can just create another bf, best friend, just kidding, no, binary format, memory stream, and this time for memory stream, we're going to give it an argument, and that argument is going to be packet bytes, because it was serialized into a memory stream, so it can be deserialized from one. So basically we're going to create a packet, p is equal to new, we're actually going to cast it, because you need to cast it, and then we're going to do bf.deserialize ms. That's basically what that does. It's going to deserialize this byte array, which is held in this memory stream, into a packet. It's going to cast it as packet. So this is basically the packet that we want. And basically from there we can just do this dot gdata is equal to p dot gdata dot packet is equal to p dot packet int, this dot bool is equal to p dot packet bool, this dot sender. Oh no, we don't want this. Yeah, we do. Sender int is equal. So packet type is equal to p dot packet type. Okay. So you have to remember, if you ever add or remove anything from here in your packet after you've built this method, you have to remember to go back and change this. Otherwise, it's gonna send you for a loop. But oh, guess what I forgot to do? I forgot to close my stream. So if you're familiar with serialization, you're gonna see that a problem with this situation. And that's because we haven't flagged our packet object as serializable yet. So it's going to throw some sort of exception if we try and serialize it without having this attribute at the top. Attribute, excuse me. So, and so from here, we can now handle data, and this is just how I'm going to handle it for now. But we're going to create packet, seal new packet, and we're just going to give it that buffer as a parameter, because we created a constructor that deserializes that into a packet. And from there we can build our data manager method, and our server will be just about wrapped up. Public void data manager packet p, and data needs to be static. I forgot about that. Sorry, 1 second. Sorry about that, got a phone call, you know, gotta take the phone calls. Basically we're gonna give data manager a packet. There we go. So, I think we can kind of close up our data and we can close up our listen thread. And basically everything that we want to do from here on out, we can do in our data manager. But we don't want to do that. We want to go over to the client side. And oh god, we haven't even started this. Oh great, okay. Yeah, that's a lot of code, but basically we're going to need using system.net, and we're using system.net.sockets, and using system.io, system.threading. So our client's going to be very similar to our server, except for it's not going to be listening for clients. And it's only going to have one data manager thread. So we're going to go ahead and create a public socket. We're going to name it master, for just being the master socket. But I think that's all we need for now. So in the main, we're going to go and tell it to give me an IP. Actually, no, take it back. Going back to the server thing, we're just going to do, going to get it some input. So console.writeLine starting server on plus packet.get IP4 address. Okay. So now when we start a server, actually I'm just gonna run this just for the sake of seeing if it works. Yeah, and you're gonna need to let it through your firewall because otherwise you're gonna have a bad time. So starting server. So now we can see the IP address on our server when we want to connect from our client. So go ahead and do console write Azure host IP address. Ah, God, sorry, I'm having fits today. So string IP is equals to console.read line. And we're not going to bother with much error handling at the moment. I'm just kind of trying to give you guys the gist of it. But basically, to make sure that's an invalid IP address, you can do try and then IP address parse IP. And if it throws an error, if an exception because it's not a valid IP address, you can just loop back to the top and tell them that you done fucked up. But basically, see, where do we want to go from here? Oh, we need to initialize our master socket. So, oh god, this needs to be solving consoles. I keep reading about that. But like, static master. Okay. So master is equal to new socket. And we're just going to initialize this like we did in the server. Address family internetwork socket type stream and protocol type TCP. So, what you're talking about? Okay, there we go. So we're going to create another IP endpoint here. IP endpoint, IP is equal to new IP endpoint. And we're going to do IP address parse IP. And port, I think we use 4242, right? So we're going to try and do master.connect to IP. And now, okay, this is one section. I do want to have error handling. What's going on? Oh, I see. Name IPE then. Okay. So this is something where I do want to have error handling because this is kind of an important spot to have error handling. But I'm going to go and do try and do catch. And it doesn't really matter what basically what we're saying is that if you can't connect, like if the IP address is invalid, then something, obviously something went wrong. I'm going to do console.write line. It could not connect to host. And I'm just going to put a console. They tell you, say you should never do this, but I do anyway. I'm just going to throw go to A in there. So basically, what we're doing is we're trying to connect, and if it can't connect, it's going to say you're a bitch, and then go to A. Actually, I want to throw a little thread sleep. So it's going to let you read this message before it kicks you back up to the top, but format that. Okay. So from here, we need, like our server, we need a data listener, not a client listener, but like an actual data listener. So public, so it doesn't need public, static void data in. And since we're just going off of a master socket, we don't actually need to give this one a parameter. But so from here we're going to go ahead and do our regular byte. I'm just going to kind of code right through this so save time because it's the same thing essentially. I'll actually speed this up in the video if I can. We don't really need an else statement here just because, right? And then we're going to need a static data manager and go to packet P. There we go. All right, so that should, for the most part, be our client. But basically, there's really nothing happening here. So, what I did forget to do is start this thread. So thread t is equal to new thread data in t start. Okay. So what we want to have going here is actually we want it to be a chat. So we need to write, let's do console dot console.write. You know, there's one more thing I want to do here. I lied. I'm sorry. I want to have a public static. Since we're doing a chat room, static string name. So when you start the server, we're just going to have it be console.write and enter your name. Okay, and then also needs the static string ID. Okay, wow, we actually have quite a bit left. Great. Okay, I was being sarcastic, but console.write. I'm just gonna do a little boop. There we go. Okay. So actually there's one thing I forgot to do, and that is to send a registration. So I'm going to create a packet type, registration. And I don't know what the correct terminology is. I just call it registration because why not? But basically in our listen thread, we actually want to have it send. So when we're going to put that in the constructor. Here, I'm just going to get public. Void send registration packet. Okay. So I'm going to call that in each of our constructors. Send registration packet and send registration packet. And basically, what we're going to do here is going to do packet p is equal to new packet, and we do packet type dot registration. God, man, that's early. I'm sorry. So, basically, why I like using the lists of strings is you can do things like p.senderID is equal to ID, and p. Let's see, what else we need? I think that's about it, isn't it? What are you talking about, Willis? Oh, sender ID. Oh, wow, we don't even need to assign it. Yeah, so I think that's actually all we need because we're just sending it the ID. So from there we can just do client socket dot send and p.2bytes, and that will send our packet to the client. And because this client socket is the one that was accepted in our listen thread, it should be the one that's on the client side of things. So great opportunity to use our data manager. Let's go ahead and throw a switch statement here, p.type packet type. I'm going to go ahead and do case packet type dot registration and go into do console write line. Received a packet for registration. Responding. Okay, so let's see if this works. We're going to build, when you want to build the entire solution, you're just going to right click there and do build solution. But let's see, I wonder if I can just open it. There we go. We want the server bin debug. Okay, so we're gonna run our server. We're gonna allow it. Yes, it's not a virus. At least I'm pretty sure it's not a virus. I'd be kind of worried if it was a virus, but okay. Name. Let's do Dro and 192.168.0.5. Okay, so we know that it works. So basically what happened here is we connected and it went through our code and it connected to the server, and the server's like, hey, I just had a client connect to me, and the client sends back this registration packet. So now what we need to do is have this is another problem we'll address later, but basically what we want to do here is have it respond. So we're going to create a packet, P is new RP for return packet new. We're going to go ahead and do packet type dot, oh wait, excuse me, we need the signer ID. So this dot, what are you talking about? It's in the same class, right? Yeah. This dot that's weird. This ID is equal to P dot sender ID. Oh no, that's where I was getting thrown off. So we're just go ahead and do server and ps dot gdata dot add ID. Okay, so we know it's coming from the server and the ID is what we want it to. So ID is equal to p.gdata, and we're just going to give it 0 since it's the first thing. Okay, so now we need to respond. So packet P is equal to new packet, and packet type dot registration. And basically we're just going to give the server our name. In fact, I'm going to put that in the client data class. Name. I lied, I'm not going to do that. So we actually don't need to respond. We can just delete that. This entire thing, actually. Okay, so basically we have our ID, the server knows we're connected. Now what we want to do is be able to broadcast messages, because it is a chat room. So what I'm going to do is do I'm going to create another packet type over in our enum, comma, comma, chat. And that's going to create a chat packet type. So, FFS, man. Just kidding. So packet P is equal to new packet type dot chat, and I go ahead and get ID. And basically we're just going to do p.gdata add. Actually, for the first object, why don't we add the name and then p.gdata? You'll see where I'm going with this later. p.gdata add input and master.send p.2 bytes. Okay, there we go. So basically, what this is going to do is it's going to get our input, like what we write, and then it's going to send that to the server. And basically, the server now needs to take that information, switch p.packet type. God, it's so difficult for me to type today. Case p. Type.chat. Okay. So what we want to do, we essentially just want to forward this packet to all of the connected clients. So we're just going to go ahead and do for each client data cin clients. There we go. We're just going to do c.client.send p.2 bytes. Okay. So that's just a little algorithm just to forward the packet to all connected clients, I guess you could say. Has some uses. I'll go over that a bit later, maybe not. But basically now we need to come back to the client, because you got to remember there's two sides of this. So we need to come back here and create another case statement, case packet type dot chat break. Okay. So basically you just want to write the data. So we're going to write console.writeLine p.gdata 0 and plus p.gdata 1. because the first one we know is our name, and the second one is the message. So it's going to write the name, colon, and then the message. But we want to make this look pretty, so console foreground color, or actually console color. Console foreground color. That's cyan. Console dot. Okay. I want to do so the foreground color is equal to C. Alright, so that's just kind of like making it look pretty. So I'm going to rebuild this. I'm going to see how it works because it should be just about done. Run the server, run the client, Joe, and we're going to do 192.168.0.5. It's connect. So it is connected. So basically, since I'm not sending any data, it's just saying, yeah, Joe said this, so let's go. This is a string. And obviously the formatting's a bit off, but it is working. And if I were to start another client up here, it's like a server client bin debug client Joe Bob 192.168, just to prove that it works. So we now have our server, and we can put in some information like some feedback in our server if we want, but at the moment I'm not going to bother doing that. So hi Joe, this is Bob. So basically it's going to broadcast it to everyone, but as you can see, Bob got it too. And you can have any sort of data running between two, and that is the problem. The last thing I want to go over is that error that just came up, the big ugly error. So we're going to set this as our startup project. Oh, by the way, if you want to just debug any of these, just to set a startup project. And you can't obviously accept for the server data because that's a library. But this is a lengthy video. Fantastic. Yeah. So we're going to have it connect 192.168.0.5. And then we're going to disconnect. Basically, this error happens because it's connected, and C# just doesn't naturally know what to do if a socket becomes disconnected, because it's like, hey, this is supposed to be connected, right? So what we're going to do, I believe, is just throw this entire thing into a try catch. And then we can manage our exceptions from there. Just catch socket exception EX. We'll go ahead and do console.writeLine a client disconnected. And then we're going to do the same thing over the client side. I want to see exactly where that breaks, just it's easier. So I'm going to build that. Start debug. Let's go to the server. Joe 192.168.0.5. So if I just close the server, it's going to go, meh. So put this whole thing into a try. Catch once socket exception EX console.writeLine. The server has disconnected. Okay, so in theory what this should do is let us handle connections like that, and then from there, obviously I'm running way longer than I hope to, so I'm not going to go into the details, but basically you can just have it go back to the main menu. There's a lot of different stuff. This is just a basic platform. See if I close that, see the server's disconnected. And I go ahead and throw console.readline and console and environment.exit 0. Okay, so that should just about do it. Thanks you guys for watching. This is kind of like a basic version of it. You can, from here, this is kind of like a platform to build off of. You can go to a lot of different directions. I built a game recently. It was kind of like that. It's just kind of, let's see if I can find it here. I think I had it back in my 2012 projects. Yeah, called it Lead Hacksaw. But basically, what I did with that is it's basically a console-based game, and you're trying to, quote, hack everyone else off the network. But yeah, it turns into a lot of code, as you can see. and I have four different projects in here. But there's a client. You can kind of see the same thing. It goes off of this join server, enter host IP. It creates this. It connects to it. Couldn't connect to host, and then it does all of this. And don't worry about most of that. That's just part of the game. But data manager in, as you can see, it does all of that. It's essentially the same thing. So there's a lot you can do with this this platform, I guess you could say. But it's just a nice, easy way to build a multi-threaded server. And I know it doesn't seem simple, but compared to some of the other solutions there are out there, it is a fairly simple way to accomplish a multi-threaded server, especially using sockets. But anyway, thank you guys for watching. I've got a few other tutorials. I'm going to try and get some more up. I haven't been active in quite a while, so I'm going to try and get back on that. But anyway, thank you again, and I hope to see you in a later video.